Welcome to A-Level and AP Physics. In today's lesson, we will discuss some typical type of questions on waves from Specimen Paper 1 for 2022 exam. For question number 21, it is given to us a wave has time period capital T and wavelength lambda and amplitude A. The wave is shown on a graph of displacement x against distance t. We need to find out which graph is correctly labeled. Now, if you look at graph A, in this case, you can see on x-axis we have distance and on y-axis we have displacement. So this one is the amplitude. Amplitude is the maximum displacement from the rest position. So this one is correct. And lambda is the distance between two identical points on the wave. Means the shortest distance between two identical points on the wave. That is called lambda. Or simply we can say it is the distance between two consecutive crests, or it is the distance between two consecutive troughs. So this is also lambda. We can also say this one is the lambda. The distance between two consecutive troughs, that is also lambda. So this is labeled right. So our answer for this question is A. Now if you look at option B is incorrect because this is time period. This cannot be time period. This can be lambda because x-axis is distance. So this one is wrong, but amplitude is labeled correct. So that's reason B is not answer. If you look at option C, this is also not correct option because this is labeled time period, but x-axis is distance. So it can be lambda, but it cannot be time period. If this is time period, x-axis has to be time. Now if you look at option D, in this case this one is correct, but if you look at amplitude, this one is wrong because amplitude is the maximum displacement from equilibrium. So this one is the amplitude, but this is 2 times of amplitude. So this option is wrong. For question number 22, it is given to us a vehicle emits sound of a constant frequency. A stationary observer hears the sound. The vehicle moves directly towards the observer at constant speed. The observer hears sound of frequency f0. The vehicle then accelerates. So we will take this one, case 1. Still moving towards observer. Travels at a higher steady speed for a certain period of time. So we can say this one is the second case. And then decelerate until it stops. So this one will be the third case. So we will say this is third case. Question is asking us what is the variation in the frequency of the sound that is heard by the observer. Now let's try to sketch the speed time graph for the motion of the vehicle. In this case we will sketch speed on y-axis. So this is the speed on y-axis and we have time on x-axis. For this question which is given to us, the vehicle is moving at constant speed and then it accelerates. So we will take initial speed of the car, means vehicle v0, then it accelerates to certain maximum speed, then it continue moving at that steady speed for a while, then it finally decelerate to stop, decelerate to rest, means its final speed is equal to 0. And this is our case 1 and this one is our second case and this one is the third case. Now we will look at all these cases one by one. First of all, we will discuss when the car is accelerating. So I will simply write down here when the car is accelerating and the speed Vs, this is the speed of the vehicle, means speed of the source. As it is given to us, speed of the source is increasing. Now we can use Doppler equation. F observed has to be equal to speed of the wave divided by speed of the wave, means speed of the sound minus speed of the source. And this one has to be multiplied with frequency of the source. In this case, Vs is increasing with time. If Vs increase with time, it means V minus Vs. This will decrease with time. If this decrease with time, it simply means that observed frequency will increase. Or simply we will say observed frequency will rise. So I will simply write down here. It will rise with time. So this is when the car is accelerating. Now if we go to the second case, for second case, it is given to us speed of the car is constant. So we will write on here speed of the car is constant. Again we check this. Again we can check this one with Doppler equation when the source is approaching. So we can use F naught is equal to V over V minus Vs times frequency of the source. In this case, Vs is constant. It means observed frequency will stay constant. So we can say is steady or it remain constant. Now let's try to understand what is happening in third case. For third case, it is given to us car is decelerating. It simply means that speed of the source is decreasing with time. So again, we can use F naught is equal to V over V minus Vs times frequency of the source. Source is still approaching. That's the reason we are using V over V minus Vs. But in this case, Vs is decreasing with time. As Vs is decreasing with time, it simply means that V minus Vs is increasing with time. If this is increasing with time, it means that F naught is decreasing with time. So this is what is happening in third case. Now let's try to compare the frequency observed when the source is moving at speed V naught and the frequency observed when the source is at rest. We will say frequency observed when the source is moving at speed V naught F naught I, and the frequency observed when the source is at rest, we will say this is over final observed frequency. Now if you look at initial observed frequency, simply we can say F naught I, this is equal to V over V minus V naught. V naught is the speed of the source and this is multiplied with frequency of the source. In this case, V naught, this is greater than 0. So simply I will write down here, this is greater than 0. It means that V minus V naught is smaller than V. So we can say V minus V naught, this is smaller than V. As this is smaller than V, so it simply means that this is smaller than V. So F naught I, this is greater than Fs. So we will say F naught I is greater than Fs. So observed frequency is greater than Fs. Now if you look at final observed frequency, F naught F, this is equal to V over V minus 0 and this is multiplied with Fs. So in this case, simply you can see this V will be cancelled with this V. In this case, final observed frequency is simply equal to frequency of the source. Final observed frequency is less than initial observed frequency. Very important point. We need this one for the answer. Now if you look at option C now, for option C it is given to us observed frequency will rise, then remain steady, then fall to a lower frequency than F naught, means lower than F naught I. So this is true. So this is what is happening. We have rise, then frequency stays same, then frequency decreases to frequency of the source, and the final observed frequency is lower than initial observed frequency when the source was moving at speed V naught. So the answer for this question is C. D is not answer because this is telling us return to frequency F naught, not it returned to Fs. So this one is wrong. So D is not right answer. First one is not answer. Fall, this is wrong. Fall, this is wrong. So A is not answer, B is not answer. For this question, it is given to us a car traveling in a straight line at a speed of 30 meters per second passes near a stationary observer while sounding its horn. The frequency of sound emitted by the horn is 400 Hz. Speed of sound in air is given and this is equal to 336 meters per second. We need to find out what is the change in the frequency of the sound heard by the observer as the car passes. It simply means that car is approaching observer first of all. So this is the first case. Car is approaching observer and then this car is moving away from observer. In this case, we need to find out what is the change in frequency. So the first thing we need to understand, when the car is approaching, we can find out observed frequency by observer. So F observed will be equal to V over V minus Vs time frequency of the source. And for the second case, when source is moving away from observer, we can also find out observed frequency. This will be equal to V over V plus Vs times Fs. But the question is asking us to calculate the change in the frequency. So we need to understand frequency observed when the source is approaching will be greater than frequency observed when the source is moving away. For approaching, so this is the case when it is approaching. So I will write on here approaching, in this case when the source is moving away. When the source is approaching, I will be using F naught A for approaching, and when the source is moving away, I will be using F naught M. Now simply we need to find the difference between these two. Delta F we need to find out. So I will simply write down F naught A minus F naught M. Now we can plug in values. F naught A we have, this is equal to V over V minus Vs multiplied by Fs, minus we have V over V plus Vs multiplied by Fs. Now simply we need to plug in values. Speed of wave is given. This is 336 divided by 336 minus speed of the source 30 meters per second. Frequency of source is given 400. And now we need to plug in values for speed of wave again when the source is moving away, and speed of wave in the medium means speed of sound plus speed of source, that is 30 meters per second. And this one we have to multiply with frequency of the source, and frequency of the source is 400. Now simply we need to solve this one. If we calculate, in this case our final answer will be equal to 72 Hertz, and this is the change in frequency heard by this observer when the car passes this observer. So the answer for this question is C. Question number 24 is about electromagnetic spectrum. For this question we need to find out which list shows electromagnetic waves in order of increasing frequency. So first of all, let's try to understand electromagnetic spectrum. One way to remember electromagnetic spectrum is, you can simply remember Granny's Xbox. Granny's Xbox use volts in my room. Volts in my room. This is way to remember order of electromagnetic waves. G here for gamma radiations, or you can say for gamma waves. X here for X-rays. U here for UV means ultraviolet. V here for visible light. I here for infrared. So I for infrared, and M for microwaves. So M is for microwaves, and R for radio waves. Now if we go from radio to gamma waves, frequency of the waves is increasing and energy of the wave also increase. But if we go from gamma to radio waves, wavelength of the waves increases. But for this question we need to find out in order of increasing frequency, means from radio to gamma waves. So if you look at option A, radio waves is right. After radio has to be infrared, then ultraviolet, then gamma. So this order is wrong. If you look at option B, we have radio waves. So the first one we have radio waves. So the radio waves is here. Then we have infrared. Infrared is here. Then we have ultraviolet. So you can see ultraviolet is here. And the last one is gamma. Gamma rays. So this is in order of increasing frequency. So B is correct option. Now if you look at C, we have ultraviolet, then we have gamma, but again we have radio. So this order is wrong. So frequency is decreasing, gamma to radio. If you look at option D, ultraviolet, infrared, this is wrong. So this is going ultraviolet to infrared. Frequency is decreasing. So this order is not correct. That's the reason answer is B. For question number 25, it is given to us the diagram shows a steel wire fixed at one end. The other end of the wire is attached to a weight, and the weight is hanging over a balloon. An oscillator is attached to the wire near the fixed end. A stationary wave with one loop is produced, and the frequency of the oscillator is F. Which frequency of the oscillator produces a stationary wave with two loops? Now in this case we need to understand. Imagine that this is L of the wire. So simply we can say this is L of the wire, means the length of the wire from this point to this point. In this case we also need to understand this point is a node, this point is a node, and the distance between any two consecutive nodes or antinodes is equal to lambda by 2. So in this case lambda by 2, this is equal to L. So we can say lambda is equal to 2L. So this is how we can find out lambda. Now let's try to understand the second case when the stationary wave has two loops. So simply we need to draw two loops here. So imagine that here is another node. So the first loop is this one. So we will have first loop here, and this one will be the second loop. So we have two loops now. So in this case again we need to understand the distance between any two consecutive nodes is equal to lambda by 2. So distance from here to here is lambda by 2, and distance from this node to next node is also lambda by 2. So in this case L is equal to lambda by 2 plus lambda by 2, or simply we can say L is equal to 2 times lambda by 2, or simply this is equal to lambda. Now in this case you can see lambda is equal to 2L, but now lambda is only equal to L. So it means lambda has been decreased, or lambda is half. Now if you get V is equal to F lambda, if lambda become half, it decreases to half, frequency has to increase by 2. So the frequency has to be double. So that's the reason answer is C. Lambda becomes half, frequency increases to double, 2 times. For question number 26, we need to find out which statement gives a condition for diffraction to occur. First of all, let's try to understand a little bit about diffraction. What exactly diffraction is? Diffraction is simply spreading out of waves. So we can simply write down diffraction is spreading out of waves as they pass through a gap, or you can say hole. We can also say pass around an obstacle or an object. Pass around an object, or we can say obstacle or obstacle. So this is how diffraction is defined. Now let me show you this one with the help of figures. If you look at these two figures, you can simply see that in this case when these waves they pass through the gap, so we have these two waves here, as they pass through this gap they spread out. So you can see they can reach behind the obstacle, so they spread out. So you can see this part is telling us they spread out. So now they can reach behind the obstacle. So this is telling us they spread out. They can reach behind the obstacle. So this is diffraction. And also we need to understand part of the wave is actually blocked. Part of the wave is blocked. Means this part of the wave cannot pass through the hole. If you look at this second figure, in this case you can see we have object, or you can say this is the obstacle that is in front of waves. So this one is the obstacle. This part of the wave, this one is blocked. Partially means part of the wave, this has been blocked, and the remaining part of the wave, this can pass through, and it's spread behind this obstacle. So this is another example of diffraction. This part of the wave has been blocked. Now based on these things we can find out the right answer. If you look at option B in this case, a wave is partially blocked by an obstacle, because this part of the wave has been blocked by this obstacle. So this is example of diffraction. A little bit tricky question, but this is one point you need to understand about diffraction. We can also say a wave is partially blocked by an obstacle, and this is the condition. You can see in this case part of the wave is blocked, and the part which passes through this gap, that's spread out. And the same is true here. Part of the wave means the wave is partially blocked, and the part of the wave which passes around this obstacle, that's spread out, and it can reach behind the obstacle. So these are few points first we have to understand about diffraction. So that's the reason our answer for this question is this. For question number 27, it is given to us a parallel beam of light of wavelength 600 nanometer is incident normally on a diffraction grating. Grating has 300 lines per millimeter. We need to find out what is the total number of intensity maxima from the grating. First thing we need to understand, this question is about diffraction grating. So it simply means that we can use n lambda is equal to d sine of theta. Question is asking us about total number of intensity maxima. We have to consider angle 90 degrees. So this is one thing you need to understand. For intensity maximum, we have to use theta 90 degrees. And the second, we also need to understand sine of 90 degrees. This is equal to 1. Now from here, I can simply say n maximum on one side times lambda. This is simply equal to d times 1. Because sine of 90 is 1. We need to find out n max. So the n max simply is equal to d over lambda. But well, if d is not given to us, grating has 300 lines per millimeter. So we can find out value of d. D will be equal to 1 over n. In this case, we have 300 lines per millimeter. So n is equal to 300 lines per millimeter. So means 1 mm per millimeter. Simply we can say 1 millimeter we have to convert into meters, SI units, divided by 300. Now simply this value of d we can plug in here. So d is equal to 10 to the power of negative 3 divided by 300. And this one is multiplied with 1 over lambda. And the value of the lambda is given. This is 600 nanometers, means 600 times 10 to negative 9. Now we need to solve this one for n max. If we solve this one for n max, our final answer will be 5.55. So this is value of n max, 5.55. We need to find out total number of intensity maximum. If you look at diffraction grating, so this is diffraction grating. Simply you can understand this is diffraction grating. Here we have screen. On this screen we will get center maximum. So n for this one is equal to 0. Then we will get an other bright fringe. N is equal to 1, and here we will get n is equal to 2. Here we will get another intensity maxima, n is equal to 3, and 4 and 5. So we have calculated 5 on one side, but there also will be 5 on the other side, n minus 1. So here we will have n is equal to negative 2, n is equal to minus 3, 5 here. So n total, so simply you need to understand n total, this is equal to 2 times of n max plus 1, means 1 we have at the center. So in this case we have 2 times 5 plus 1. So we have total intensity maxima equal to 11. So the answer for this question is C. C is the right answer. For question number 28, it is given to us a pattern of interference fringes is produced using a red laser, a double slit and a screen. So first of all, let's try to sketch double slit. In this case, simply means that we have 2 slits and here is 1 screen. In this case, we will have 1 center maxima and will be equal to 0. Then we will have another maxima, intensity maxima, and will be equal to 1. So this is another bright fringe. Another bright fringe after this one. So this is n is equal to 2. Now we need to understand the distance between center to center of these 2 slits is called slit separation, and we use letter A for that. Slit separation. So let me write down here. So this is slit separation. And the distance between 2 bright fringes, this distance, this is x, and this is called fringe spacing. So let me write down here. This is called fringe spacing. Fringe spacing. For this question, it is given to us the screen is 3.5 meters from the double slit. It simply means that the distance between slits and the screen means this distance is given, and this is capital D. Capital D is equal to 3.5 meters. This one is over screen. It is also given to us the light from the laser has a wavelength of 640 nanometers. Lambda is given to us. The pattern of the fringes is shown. But if if you look at this now, we have bright fringe, then we have another bright fringe. So the distance between two bright fringes, this is equal to 1x. So here we have another x. So I will be writing here another x. Here we have another x, and here we have another x. So in this case, simply you can see we have 4x. So we can say 4x is equal to 72 millimeters. So the value of x is equal to 72 divided by 4, and this one will be equal to 18 millimeters. So this is value of fringe spacing, and this is the most difficult part of this question. Most of the students, they cannot figure out value of x. So this is value of x. We need to find out separation of the slits. Means we need to find out what is value of a. For double slit, we need to understand ax is equal to lambda times d. We need to find out a, so it simply means that a is equal to lambda d over x. Lambda is given to us, that is equal to 640 nanometers. So we have to multiply with 10 to negative 9. D is given, that is 3.5 meters. So this is 3.5 meters. We have to divide by x. X is equal to 18 millimeters. Now simply we need to solve this one for a. If we solve this one for a, our final answer will be 1.2 times 10 to negative 4 meters. So the answer for this question is A. The main takeaway from this question is x is the distance between two consecutive bright fringes. So that is the main takeaway. Distance between two consecutive bright fringes is equal to x, and this is called fringe spacing.